Okay, so we've got a question here involving an exponential function. We know that because of the information given to us. It's a general function. The y values are found by doing p times q to the power of something. So here's where the exponential bit comes in. The curve passes through some points, so that's important to us, and it says calculate the value of p and q. So in other words, we've got to solve this function here. Because it's got two letters, we need two equations. So let's have a look. We've got coordinates, so we must remember that the coordinates tell me that when 1, 5 happens, then the x value is 1 and the y value is 5. So from the general function, y equals p q to the power of x, then we can put the values in and create one equation. So when y is 5, p times q to the power of 1, because it's q to the power of x, so x is 1, then that's one equation created. The other coordinate then will tell me that when x is 4, y is 320. So again, using the general function they've told us, we know that 320 must equal the p value times q, and this time the power is 4. Now when you've got questions involving exponential functions and they're doing the general equation y equals p times q to the power of something, then the standard way of approaching this is that we need to remove one of the letters. So we've got two equations, and because it's an exponential function, we always divide the functions to cancel one of the letters to 1. So we've got 320 over 5 equals p times q to the power of 4 over p times q to the power of 1. That means the p is cancelled to 1. 320 divided by 5 is 64. Q to the power of 4 divided by q to the power of 1. To take away the powers because it's the same basis, so that's q cubed. So we're looking for something cubed to give us 64. We should realise that that is 4, because we're doing the cube root of 64 equals q, so q equals 4. That then tells us that our function now can be written as y equals p times 4 to the power of x, because we now know that it's about the 4 power series, because q has got a value of 4. Again, we can use one of the equations to keep the numbers simple, so I'm going to use this one to find the value of p. So we know that 5 is equal to p times the q value, which is 4, to the power of 1. So 5 equals p times, well, 4 to the power of 1 is 4. I just need the value of p, so rearrange by dividing, opposite to timesing, divide. So 5 divided by 4 equals p. So the answer here is going to be 5/4. You could simplify that to 1/5 if you like. But that's how we solve equations involving exponential functions. We can use the coordinates to create values for the x and y in the function, two variables to find, p and q. Therefore we need two equations, one there, one there. And with this kind of question, by dividing, we always cancel p out, and then we can get a function involving q, and we can then solve it, and then use that q value to then find the p value. Now, sometimes in these questions, they're nice to you. They might do something like this, and they'll tell you this coordinate is something maybe 0, 720, and then that automatically, because this is happening when this is 0, that automatically tells you the p value. So sometimes you can be lucky and they might tell you that's a point there, and therefore that automatically tells me this is the p value. Just because whatever that is, q to the power of 0 is 1. So in the function y equals p q to the x, that would become 1. So the y value must be the same as the p value at the point 0. So look for that as well. There's a quick way of getting p values. But otherwise, that's an example of how you can solve an exponential function to find